Okay, so good morning everyone. Good morning, sir. We are group number 7 and we are tasked to discuss the propeller aerodynamic process. So propeller aerodynamic process consists of work, power, slip, and geometrical pitch. So I was assigned to discuss the part of work. So let's start. An aircraft moving through the air creates a drag force opposing its forward motion. If an aircraft is to fly on a level path, there must be a force applied to it that is equal to the drag but acting forward. So this drag, which is acting forward, is what we call or force, but is acting forward is called thrust. Okay, so the work done by thrust is equals to the thrust times the distance it moves the aircraft. In short, in order for us to calculate the distance, we use this formula. W is equals to thrust multiplied by our distance. Ano, nakasimple lang pag-calculate sa atong works sa propeller. To give you more idea, I have here a problem. Nagready ko I think 2 problems. Simple na kayo na siya calculations like mga high school makakuha galing even elementary. Okay, so we have here problem number 1. A small aircraft propeller generates a constant thrust of 500 newtons. If the aircraft travels a distance of 1,000 meters during a flight, calculate the work done by the propeller. So we will use our formula, which is W is equals to thrust multiplied by our distance. So next, atong given hatag, which are given is we have our thrust, which is equals to the thrust is equals to 500 newtons, and our distance is equals to 1,000 meters. So we have our formula naman, diba? So our formula is equals to thrust multiplied by our distance. Thrust times distance. So ito siya ikuan our thrust is 500 newtons multiplied by our distance, which is 1,000 meters. If ato gamiton og calculator, if we use our calculator, we will get work is equals to pila 500 times 1,000, 50,000, diba? 50,000 joules or J ra. Okay na, J will do. So that's how we calculate for our work. Simple ra kayo. Thrust multiply your distance. Okay, so kasi wonder mo anong naggamit tag formula nga joules or J. Kay according to my research, in physics, work is measured in joules or J. This money joules or J. Joules are the standard unit of energy, and work done is a form of energy transfer. Okay, so when an object is moved by a force, example lang sa number 2, an object it pushes an object a distance. So a thrust pushes an object a distance. So when an object is moved by a force over a distance, work is done at that object. Okay, so if an object now is staying and a force was applied to the object, there is work done on that object, and this work results in change of the object's energy. So that's why we're using our joules. Okay, basta na wonder ba kung joules ang gamit nga pa, it's because work is measured in joules man daw. So we will use this according sa internet. So yeah, that's it for my part. Thank you.
So good morning, sir. I'm Kenneth from Group 7, and I'm here to tackle about the propeller's aerodynamic process. So let's start. So the power of propeller aerodynamic process refers to the work the propeller does generate thrust and propel the aircraft forward. That power depends on the design of the propeller, includes its shape, size, and blade angle, as well as rotational speed. The engine provides mechanical power, which the propeller converts into thrust, which is a type of aerodynamic force. The efficiency of this convention process depends on several factors, including the design of the propeller and its operating conditions. By the way, the formulas we're gonna use is thrust, mass flow rate, exhaust velocity, mass, and acceleration. So we have an example here. So this is my first example. A space cargo is delivered to orbit using a rocket that has a mass flow rate of 2,200 kilograms and an exhaust velocity of 2,000 meters. Step 1. For this case, the given quantities are the mass flow rate and the exhaust velocity. Note that these quantities go together, so you should write down the quantities that follows as follows. Mass flow rate 2,200 kilograms per second. Exhaust velocity 2,900 meters per second. So step 2. Check the units and do conversions when necessary to obtain the final unit of the required quantity. Step 3. Substitute the given value into formula. The given quantities are the mass flow rate and the exhaust velocity. Use the formula thrust, mass flow rate, and exhaust velocity. Substitute the quantities. Mass flow rate equals 2,200 kilograms per second and the exhaust rate equals 2,900 meters per second into formula. Step 4. Calculate to obtain the required value and use the appropriate unit. The thrust can also be written as thrust equals 6,380 Newton, where the equivalent unit of Newton is used.
Good day, sir. This is my part, the slip part in propeller aerodynamics. The slip in propeller aerodynamics refers to the difference between the actual and the theoretical forward movement of an aircraft per one rotation of the propeller. This difference arises due to the angle of attack of the blades and the induced airflow around the blades. Here's a basic explanation along with an example calculation. Actual forward movement. This is the distance the aircraft actually moves forward in one rotation of the propeller. Theoretical forward movement. This is the distance the aircraft would move forward if there were no slip. It's calculated using the pitch of the propeller, which is the distance it would move forward in one rotation if it were moving through a solid medium. Slip. The slip is the difference between the actual and theoretical forward movements. It's usually expressed as a percentage. Example calculation. Let's say a propeller has a pitch of 50 inches, the theoretical forward movement. And in reality, the aircraft moves forward by 45 inches, the actual forward movement. So, this is the calculation. Slip equals theoretical forward movement minus actual forward movement divided by theoretical forward movement and multiplied by 100. So, slip equals 50 inches minus 45 inches divided by 50 and multiplied by 100. So the next equation is, the answer is 5 divided by 50 inches, the theoretical forward movement, and multiplied by 100. So we have an answer of 0.1 and we multiplied it by 100. So we got 10%. Got 10. It's 10%. So in this example, the slip of the propeller is 10%, means that the aircraft moves forward 10% less than what would be expected if there were no slip. That's all. Thank you. This would be my visual representation of the slip in propellers. So the short arrow means that this is the actual forward movement, and it is 10% shorter than the theoretical forward movement, which is longer. And my calculation of the slip. theoretical forward movement minus actual forward movement divided by theoretical forward movement times 100.
Then geometric pitch. Geometric pitch refers to the theoretical distance a propeller would advance in one complete revolution, assuming no slip or inefficiencies. It's essentially the distance the propeller would move forward in ideal conditions. Geometric pitch is typically calculated based on the angle and dimensions of the propeller blades or threads. It's an important parameter in understanding the performance characteristics of propellers, especially in aviation. Next, geometric pitch minus effective pitch equals slip. Geometric pitch is usually expressed in pitch inches and calculated by using the following formula. GP equals 2 times R times tangent of blade angle at 75% station. R equals radius at the 75% blade station, then R equals 3.14. And this is the example on how to solve this problem. GP equals 2 times the constant times the radius times the tangent angle, where GP is geometric pitch, R is a constant, R is the radius at the 75% blade station. Tangent angle is the tangent angle of the blade angle at the 75% station. Let's say R equals 1.5, then the radius equals 0.6 meters, then the angle equals 15 degrees. Using this formula, geometric pitch equals 2 times 1.5 times 0.6 meters times the tangent of 15 degrees. First, calculate the tangent of 15 degrees. Tangent 15 degrees equals 0.2679. Now, plug the values into the formula. Geometric pitch equals 2 times 1.5 times 0.6 times 0.2679 equals 0.805 meters. So the geometric pitch would be approximately 0.805 meters. That's all for our topic on how to solve this problem using this formula. Then our group member, Cordoba Clyde Kurt for work, Walton Kenneth for power, then Absin Louie Lee for sleep, then last, Golby Eloyd for geometric pitch. I hope you understand our discussion. Thank you.